Assalamualaikum warahmatullahi taala wabarakatuh. Inshallah, we are going to begin our chapter 1 entitled as Physics and Measurement for PHL0215. So previously you've learned physics in your primary school. From Form 4 and Form 5 officially named as physics. Actually, throughout your learning of science, you are learning physics. Actually, in your primary school, you are learning things surrounding you by objective way. Okay, when we are in this level, we are talking about physics. It means that we are in the study of the basic components of the universe and their interactions. Okay, and the theories of physics have to be verified by the experimental measurement. Okay, we cannot simply say something or give a statement where the statement cannot be verified, okay, or cannot be carried out or proved by using experimental method. Okay, so if you see here, we are here actually. Okay, so this is the universe. We are here. We are very small and tiny things, and yet within our world we think this is very big enough. Okay, actually we have a bigger picture here. Okay, so we are learning the universe. Okay, and their interaction. Okay, is this attracted to this? Is this repulsive force exist? Is there any electromagnetic wave? Is there any electromagnetic force? Is there any electrical force? How about the field? So many things, right? So let's recall about your previous memory or prior knowledge about physics. When you begin officially named as physics, okay, in your Form 4 and Form 5, you are learning about the things surrounding you in objective way because you have to put it in units. When talking about one object, okay, this is a ball, the shape of it round, and it has weight, okay, it has mass means. So the mass of the first ball, the second ball is different. The first ball is heavier. How you define heavier? Okay, because amount of the mass is bigger. How you know? You have to measure it. Okay, so when you are learning physics, actually you are learning your physical surrounding in objective manner. Right, so let's begin with standards of length, mass and time. Okay, so when we talk about standards, it means that it must be the item, the material must be readily accessible, possess some properties that can be measured reliably. Doesn't matter how many thousand times you repeat the measurement, you will get the same reading. This is meaning of reliability. It will yield the same result in whatever method of measurement that you're going to use. Okay, that is how you define a standard. Okay, it will not change with time. Okay, so we have the standard of length, mass and time is kept in a museum in France, if I'm not mistaken. Right, so a physical quantity, so we are learning physical objects surrounding you, so we call it physical quantity, is one that can be measured and consists of a magnitude and unit. Okay, so the physical quantity must has units and magnitude. Okay, for example, okay, when you talk about 4.5 meter, not more than this, isn't it? So this is normally a signboard where you have a bridge. Okay, under the bridge there is another pathway for vehicle, let's say. So 4.5 meter means that the height, okay, for vehicle that can pass through under the bridge, not more than this. 4.5 is the magnitude of it. Meter here, m here is the unit of it. All right, how about this one? The speed, isn't it? The speed of the car or vehicle that passing through this road must be not more than 70 kilometer per hour. So this is a magnitude, this is a unit. Okay, so this is also another signboard, let's say. So you have the magnitude and the unit. So how to measure the physical quantity? It must has the object to be measured, okay, and then it has the tools, apparatus, okay. And when you take the reading, of course, you are going to learn how to take the reading according to the unit of your tools or apparatus. So the unit commonly used is SI units, okay. So SI unit is understood, the standard acceptable throughout the world. Alright, so basic measurement in the study of motion. This is recall a sweet memory of you. Alright, for length, okay, actually when how far, okay, when the question put there how far, okay, it involves being able to measure the distance between 2 points. How far means that it needs the information of distance between 2 points, right? When we talk about time, actually, to answer the question of how long did it take it? So, how long did it take it? This is for time. Okay, next one is mass. Okay, for mass, it's actually a measure of amount of the stuff, okay, or the material. Alright, so it's actually amount of. Okay, basic quantities are classified into two types: base quantities and derived quantities. Okay, so for example here, you have a house here, let's say. You have a house. Okay, to build a house, you need bricks. Okay, you combine, you arrange the bricks, use up the bricks, you're going to have the wall of the house. Okay, so the bricks here is considered as the base quantity of the wall, right? See, this is the basic building block of a house, basic building block. Alright, the derived quantity is like the house itself, okay, that was built up from a collection of bricks. Okay, you have the first wall, the second wall, the third wall, the fourth wall, then you're going to have house, which is the derived quantities, right? So SI unit itself, okay, International System of Units, this is understood worldwide. All the scientists, average, even common people, public people also understand what does that mean by 1 meter, 1 kilogram, okay, 1 second. Right, so basic quantity or base quantity, you have 7 actually, okay, 7: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Most probably you haven't heard about this one. Okay, we are not used to this one actually. So for the length, the name of the unit meter, the symbol of it, M. So you are used with this. This one, electric current, ampere, the symbol is A. Temperature, name of the unit Kelvin, the symbol is K, capital K. Okay, but we are used to or commonly use Celsius, right? Degree Celsius. We are going to use conversion factor later on. Right. Amount of substance, mole, the name of it, the symbol of it, MOL. Luminous intensity, the name of it, candela. Okay, the symbol of it, CD. Okay, if you combine more than one, if you have a combination of, let's say, length and mass, or mass with time, or time with current, then you're going to have a derived quantities. Okay, so let's try a workout on the derived quantity for area. Right, for area, alright, normally symbol we use for area is A, okay, which is, let's say, one kind of length, okay, times with another kind of length. Let's say length with width, length with height. Okay, it could be any of it, but both of it a kind of length. So this is a formula of it. Okay, and then in term of unit of it, alright, in term of units for area is actually meter, this is unit times with meter. So actually it's meter square. For volume, okay, for volume the symbol commonly used is V. Okay, it's actually length times with another length times with the third length. So you have a volume. Right, so in terms of units of the volumes, right, the unit of it is meter times meter times meter, which is meter cube. For density, the common symbol used is actually rho. And the formula is mass over volume. Okay, where is actually open up, volume is actually length times with the length times with the length. So in terms of units, it's kilogram over meter times with meter times with meter, which is kilogram per meter cube. Okay, now we are going to take a look on speed. Okay, for speed, okay, the symbol is similar to the velocity. It's just that speed has no direction. It only consists of magnitude. Okay, so speed is how much displacement or distance traveled by the car or vehicle or object over per unit time to have that change of distance to be done. Right. So in terms of unit of speed, okay, it's actually meter over second, commonly written as ms-1 meter per second. For acceleration, okay, it's actually how much the change of the velocity over the time taken to have that change. Right, in terms of unit for the acceleration is actually meter per second over second. So it's ms-2. For force, right, for force is defined as mass of an object times with the acceleration experienced by the object. The unit of it is kilogram dot ms-2, isn't it? So normally commonly known as equivalent to Newton. Right, so within Newton actually we have kilogram ms-2. Okay, then work out the derived quantities for pressure. Okay, pressure is defined as force per unit area. Okay, so within a force is actually Newton over meter square in terms of unit, meter square. And then within meter itself is actually kilogram ms-2 over m squared. So you can have kg m power of -1 as -2. This is actually equivalent to Pascal. So Newton per meter squared or kg m-1 as -2 is actually basic unit for Pascal. For work is equivalent to force applied to the object times with the distance traveled by the object. Right? So Newton in terms of unit, Newton times with the meter. right? Where Newton itself is kg ms negative 2 dot m, which is kg m squared s negative 2. Okay, the unit of this Newton dot meter also equivalent to or known as joule. Alright, and then next one is power. So the symbol almost the same with the pressure, but then it has different meaning. Alright, for power, the formula of power is work over time taken to have that work to be done or carried out. So it's also known as rate of doing work. So for unit of power is equivalent to the unit of job or work being done is joule, right, over the time taken, which is second. So within joule itself, okay, if we open up to this, right, so it's actually kilogram m squared s negative 2 over s, which give you kilogram m squared s negative 1. This is actually equivalent to watt, right? Equivalent to watt. Joule per second in terms of SI basic unit is kilogram meter squared over second, or simply known as watt.